Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. A store sells soda cans available in 6-pack and 12-pack. The cost of each 6-pack is $3.50 and that of each 12-pack is $5. On a certain day, the store sells X number of 6-pack soda cans and Y number of 12-pack soda cans. If the total cost of soda cans sold is $2,100 and X and Y are integers greater than 0, how many different values can X take? We start this problem by setting up a simple equation based on the information given. The first question we ask is, what is the cost of X number of 6-pack soda cans? Well, we know that one 6-pack costs $3.50. So the cost of X number of 6-pack soda cans is simply going to be 3.5 multiplied by X. And similarly, the cost of Y number of 12-pack soda cans, where each 12-pack costs $5, is going to be 5 multiplied by Y. And then if we add these two up, we'll basically get the total cost of soda cans, which is given as $2,100. So we can write this equation 3.5x plus 5y is equal to 2,100. Now the question asks for how many different values can X take. So the first thing that we do from here on is express X in terms of Y. We can do that by taking y to the 5y to the right hand side, so it becomes minus 5y, and then dividing both sides of this equation by 3.5. So we have x is equal to 2,100 by 3.5 minus 5y divided by 3.5. Now if you do the math, the first term 2,100 by 3.5 comes to 600, and then for the second term, for that fraction, 5 by 3.5, I want to get rid of the decimal in the denominator. So I multiply both the numerator and the denominator by 10. So that gives me 50 by 35. So I have x equal to 600 minus 50, y divided by 35. And then we take a step further to reduce this fraction. We can easily see that 5 is a common factor of both 50 and 35. So we divide both the numerator and the denominator by 5, and we are left with this. 50 by 35 becomes 10 by 7. So we have x is equal to 600 minus 10y by 7. Now, since x and y are both integers, for 600 minus 10y by 7 to be an integer, y has to be a multiple of 7. That's pretty clear from this equation, right? Because that's the only way x can be an integer, especially if x has to satisfy this relationship 600 minus 10y by 7, and it also has got to be an integer. Then the only way that's possible is y has to be a multiple of 7. Further note that based on this relationship x is equal to 600 minus 10y by 7, for each unique value that y can take, x will have a unique value. So if I can find how many different values y can take, I'll be able to find how many different values x can take. They're going to be the same, right? Because there's a one-to-one relationship between x and y based on this relationship. So we know that y has to be a multiple of 7. So what are the multiples of 7? It's 7 multiplied by 1, 7 multiplied by 2, and so on. I'm excluding 0 because it's given that both x and y are greater than 0. So excluding 0, the multiples of 7 are 7 multiplied by 1, 7 multiplied by 2, and so on. So the question is, how far can y go like this in terms of multiples of 7? In order to answer that, let's note one thing based on the relationship between x and y. So x is equal to 600 minus 10y by 7. And that negative sign before y tells me that as I increase the value of y, the value of x decreases. So as I keep on, increasing y to higher and higher multiples of 7, x will become less and less in value. And at some point, it's going to be 0 or negative. And we know that x has to be greater than 0. So if I can find at what point that happens, I can basically, set a limit on how far y can go in terms of multiples of 7. So let's ask this simple question. For what value of y is x equal to 0? So for that, we go back to that equation, that relationship between x and y, x equal to 600 minus 10y by 7. We plug x equal to 0, and then we have 0 equal to 600 minus 10y by 7. And from this, we get 10y by 7 equal to 600. We divide both sides of the equation by 10. So we are left with y equal to 7 multiplied by 60. So y can go up all the way in terms of multiples of 7 till 7 multiplied by 60. So let's just write the term before that, the multiple before that, that will be 7 multiplied by 59. So y can go on like this, 7 multiplied by 1, 7 multiplied by 2, all the way through 7 multiplied by 59 and 7 multiplied by 60. And for still higher multiples, those won't be allowed because for those, x will become negative. However, the problem states that not only x cannot be negative because that simply doesn't make any sense, but x has to be also greater than 0, meaning that we have to exclude that value of y for which x is 0. So 7 multiplied by 60, we just cross that out from the list of permissible values of y, because for y equal to 7 multiplied by 60, x becomes 0. So now the set of values that we have for y, is an allowable set, because for those values of y, x is going to be a positive integer greater than 0. So how many different values of y are possible? Well, we already have the list there. It's very simple to count in terms of multiples of 7. Y can take on values 7 multiplied by 1, 7 multiplied by 2, all the way through 7 multiplied by 59. So in all, y can take 59 different values. And since for each value of y, for each unique value of y, x takes on a unique value, we can conclude that x can also take 59 different values. So the correct choice in this case is going to be option C, 59.